Math Shorts.
Absolute value. The absolute value of a number is its distance from another number on a number line. Distance is a measurement that tells you how far you've gone from one point to another. The notation for absolute value is two straight lines, like this. The absolute value of 4 is 4, because 4 is 4 places from 0 on the number line. Negative 4 is also 4 places from 0 on the number line, so its absolute value is also 4. Absolute value is always a positive number because it's the distance from the other number, in this case 0, no matter the direction. Here's Lucy. She needs to walk to her tuba lesson, 3 blocks from the bus stop. After walking 2 blocks, she realizes she dropped her sheet music. She goes back 1 block, finds it, then continues to her lesson. One way to represent Lucy's journey is like this, by walking 2 blocks forward, 1 block back, and 2 blocks forward. Lucy ends up 3 blocks from the stop, yet she walked more than that. Absolute value shows us how much she actually walked. 2 blocks forward, plus 1 block back, plus 2 blocks forward, for a total of 5 blocks. Phew! Absolute value can help us calculate distance and solve math problems.
Absolute value. The absolute value of a number is its distance from 0 on the number line. The absolute value of 2 is 2. 2 is 2 units away from 0. The absolute value of negative 2 is 2. Negative 2 is 2 units away from 0 on the number line. Question number 1. 5 is located here on the number line, and it is 5 units away from 0, so its absolute value is 5. Question number 2. 0 is located here on the number line, and it is 0 units away from 0, so its absolute value is 0. Negative 7 is located here on the number line, and it is 1, 2, 3, 4, 5, 6, 7 units away from 0, so its absolute value is 7. Question number 4. 10 is a positive number. It is on the right side of 0. It is located here on the number line, and it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units away from 0. So its absolute value is 10. Negative 3 is located here on the number line, and it is 3 units away from 0, so its absolute value is 3. Negative 18 is located here on the number line, and it is 18 units to the left of 0, because it is a negative number, but it is 18 units away, so we write positive 18. An elevation of 100 feet is a distance of 100 feet away from sea level. The absolute value of 100 feet equals 100 feet. An elevation of negative 100 feet is a distance of 100 feet away from sea level, only it's below sea level. So the absolute value of negative 100 feet is 100 feet, but this time it's 100 feet below, whereas in the example above, it was above. Order and absolute value. Recognize there is a difference between the order of two numbers and the relative size of two numbers. Negative 20 compares to negative 10. Negative 20 is less than negative 10 because negative 20 is to the left of negative 10 on the number line. The absolute value of negative 20 equals 20, which is greater than 10, which equals the absolute value of negative 10, because negative 20 is further from 0 than negative 10 is. Fill in the blanks with the appropriate less than or greater than sign. Use a number line if it is helpful.
Before we go over the answers to this question, I want to share with you a little tip to help you remember greater than or less than on a number line. If a number is greater than another number on the number line, it is going to be on the right of that number. If a number is less than another number on the number line, it is going to be on the left side of that number. So when you plot numbers on a number line, the number on the right is greater than the number on the left is less than. So let's go over our answers. Question number 1. We've plotted the numbers 2 and 10. 10 is on the right side of 2, so it is greater than 2. The absolute value of 2 is 2, and the absolute value of 10 is 10. 10 again is on the right side of 2, so it is greater. Question number 2. Negative 5 compared to negative 4. Negative 4 is on the right side of negative 5, so it is greater than negative 5. Now, the absolute value of negative 5 is 5. The absolute value of 4 is 4. So 4 is located here on the number line, and 5 is located here. In this situation, 5 is on the right side, so it is greater than 4. Question number 3. We're comparing negative 7 to negative 8. We plot both on the number line. Negative 7 is to the right of negative 8, so it is greater than negative 8. Now, we're going to compare the absolute values. Negative 7's absolute value is 7 because it is 7 units away from 0. Negative 8 is 8 units away from 0. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7, 8. Now, 7 is, if we plot that now, 7 and 8 would be here on the number line. 8 is to the right of 7. The value of 8 is right of 7. So 8 is greater than 7. Question number 4. We're plotting 56 and 22. So here is 56 and here is 22. 56 is to the right, so it is greater than 22. The absolute value of 56 is 56. The absolute value of 22 is 22. So again, 56 is greater than 22.
Fill in the blanks with the appropriate less than or greater than sign. Use a number line if it is helpful.
Question number 5. We're comparing 41 to negative 37. So, compared to 0, 41 would be located here, and negative 37 would be located here. 41 is on the right side of negative 37, so it will be greater. Now we're going to compare the absolute values. The absolute values would be 41, and negative 37's absolute value would be 37. In this case, 41 is greater than 37. Question number 6. We're comparing negative 68 to negative 100. As you can see when we plot it on a number line, negative 68 is to the right of negative 100, so it is greater. Greater, right. Now we're going to compare the absolute values. The absolute value of negative 68 is 68. The absolute value of negative 100 is 100. 100 is greater than 68. Question number 7. We're comparing negative 90 to negative 30. So if we plot those on a number line, negative 30 would be located here, and negative 90 would be located here. Negative 30 is to the right, which means it's greater than negative 90. Now we're going to look at the absolute values. The absolute value of negative 30 is 30, and the absolute value of negative 90 is 90. So negative 90 is greater. Question number 8. 76 compares to negative 89. 76 is located to the right of negative 89 on a number line. Therefore, 76 is greater than negative 89. When we compare the absolute values, negative 76 equals 76, and negative 89 equals 89. In this case, 89 would be to the right of 76, so it would be greater than.
Why is driving too fast a hazard? Driving even a few miles over the speed limit increases the chances that you'll lose control of the vehicle. It increases braking distance, reduces the effectiveness of safety belts and other safety devices, and dramatically increases the severity of injuries if there is a crash. In Pennsylvania, if you go 5 miles per hour faster than these posted limits, you will get a $42.50 fine. If you go 5 miles per hour faster than other posted limits, like, you will get a $35 fine. Thereafter, for each mile over 5 miles per hour faster, you pay $2 more. Did you know that you can also get a ticket for driving too slow? Why is driving too slow a hazard? When slow drivers linger in the left lane of multi-lane roads, you may be forced to pass on the right, causing confusion and disorganization that can lead to accidents. Turning a corner and quickly catching up to a slow driver creates dangers in residential areas too. You may need to stop suddenly, which can start a chain reaction of braking that could lead to accidents or road rage. For these reasons and more, you'll often see minimum speed limits posted on roads and highways. Those caught driving below the minimum speed limit can be charged with a moving violation for blocking or impeding traffic. In Pennsylvania, the overall rule is if you have to go slow to be safe, for example, it is snowing and the roads are slippery, or if there is an accident ahead, that is allowed. Rule A, you cannot impede the movement of traffic. You cannot drive at such a slow speed as to impede the normal and reasonable movement of traffic. The word impede means to prevent. Rule B, slow-moving vehicles must drive off the road. If a person drives too slowly on a road with only one lane in each direction and impedes the reasonable movement of traffic, the driver shall safely drive completely off the roadway to allow other drivers to pass. Rule C, minimum speed limits may be posted. You have seen maximum speed limit signs. You may also see minimum speed limit signs too. At this time, there are no specific speeds or fines for driving too slow. However, you may still get a traffic ticket and a fine. In Florida, if you travel 10 miles per hour under the speed limit, you will get a traffic ticket with a $60 fine. To illustrate absolute value, let's pretend we have our own town. In our town, you will get a ticket if the difference between your speed and the speed limit is an absolute value of 15 miles per hour or more. What does this mean? It means that you will get a traffic ticket for going 15 miles per hour faster than the speed limit and going 15 miles per hour slower than the speed limit. The equation might look like this. You will get a traffic ticket if the following is true. The posted speed limit minus the driver's speed. Once you find the difference, convert that to its absolute value. If the absolute value of the difference between the speed limit and the driver's speed is greater than or equal to 15, that driver will get a traffic ticket. Let's say we have a road where the speed limit is 55 miles per hour. This young lady is driving 70 miles per hour. This is a difference of positive 15 miles per hour because she's going 15 miles per hour faster than the posted speed limit sign. Now let's say that this young man is driving 40 miles per hour on the same road. His speed is 15 miles per hour less than the posted speed limit sign. We can represent this with a negative 15. The rule for our town is that we have to find the difference between the speed limit and the car's speed. After doing that, we convert it to its absolute value. If that absolute value is greater than or equal to 15 miles per hour, then that driver will get a ticket. When driving, make sure not to drive too fast or too slow. Make sure the absolute value of the difference between your speed and the speed limit is not too great. Otherwise, you may get a ticket, or worse, be involved in an accident. Be safe. Hold on tight. We have another example that illustrates absolute value. Let's go visit the Coca-Cola factory.
1, 2, 3, 4. Rock the beat.
When companies fill soda bottles, they must decide how full is too full and how full isn't full enough. For example, when Coca-Cola fills up their 1-liter bottles, they must decide how close to exactly 1 liter must be in each bottle. Even though filling machines are calibrated to dispense the same amount each time, it isn't always perfect. That is where absolute value comes into play. After setting the machine that fills the bottles to the 1-liter mark, the company may decide that a bottle filled between 5 thousandths of a liter above or below that mark is acceptable to sell, and any difference more than that would not pass quality control and therefore not be sold. Coca-Cola's quality control may use a formula similar to this. A bottle is good to sell if the following is true. You take the difference between the amount in the bottle and 1 liter. Next, you convert that to its absolute value. If the absolute value is less than or equal to 5 thousandths of a liter, the bottle is good to sell. In a perfect world, all the bottles would be filled to exactly 1 liter. See the bottles above. However, that is not always the case. See the bottles above now. Here we marked exactly where 1 liter would be. Which bottle is perfect to sell? That's right, bottle B. Now let's take a look at bottle A. This bottle is filled to 992 thousandths of a liter. Is this bottle good to sell? Let's take a look at our formula. The actual amount of soda in the bottle is 0 and 992 thousandths of a liter. We're going to find the difference between that and 1 liter. Negative 8 thousandths of a liter. Now we convert that to its absolute value, which is 8 thousandths of a liter. Now, is this statement true? Is 8 thousandths of a liter less than or equal to 5 thousandths of a liter? This is not true, which means we do not want to sell this bottle. Let's take a look at bottle C. This bottle is filled to 1 3 thousandths of a liter. Is this bottle good to sell? Let's take a look at our formula. The actual amount of soda in the bottle is 1.003 liters. We find the difference between that amount and 1 liter. That is 0.003 liters. We convert it to its absolute value, which in this case does not change the number, and we have to ask ourselves, is 3 thousandths of a liter less than 5 thousandths of a liter? Yes, it is true. This bottle is good to sell. Now let's take a look at bottle D. This bottle is filled to 1 17 thousandths of a liter. We're going to use the formula to determine whether or not this bottle is good to sell. The actual amount of soda in the bottle is 1 17 thousandths of a liter. We find the difference between the amount in the bottle and 1 liter, 17 thousandths of a liter. We convert this to its absolute value, and in this case the number does not change. And we have to ask ourselves, is 17 thousandths of a liter less than or equal to 5 thousandths of a liter? This statement is not true. Therefore, we cannot sell this bottle of soda. Soda manufacturers are not the only companies that use absolute value. Let's look at some other examples. A regulation bowling pin should weigh 54 ounces. Before a bowling competition, officials weigh each bowling pin they plan on using. While the official weight should be 54 ounces, they allow for a difference of less than the absolute value of 4 ounces. A quality control inspector at a bowling pin competition might use the following formula to determine if a pin is regulation weight. You take the actual weight of the bowling pin and find the difference between that weight and 54 ounces. After finding the difference, you convert that difference to its absolute value. If the absolute value is less than 4 ounces, it's a good bowling pin and it can be in the competition. The weight of a box of cereal should be 20 ounces. Cereal manufacturers allow for a difference of the absolute value of 25 hundredths of an ounce. A quality control inspector might use a formula like this. First, you determine the actual weight of the box of cereal, and you find the difference between that weight and 20 ounces. Next, you convert that number or difference to its absolute value. If the absolute value is less than or equal to 25 hundredths of an ounce, it's a good box of cereal to sell. One more example. Let's visit the doctor's office. A person's normal body temperature should be 98.6 degrees. What might cause someone's body temperature to rise above 98.6 degrees? What might cause someone's body temperature to fall below 98.6 degrees? Physicians say that people's body temperatures shouldn't exceed the absolute value of 5/10 of a degree from 98.6. If a temperature does exceed the absolute value of 1/2 of a degree, this might mean the person is sick. Doctors can use the following formula to find out if a patient's temperature is in the safe range. First, they find the difference between the person's current temperature and 98.6 degrees. They convert that value to its absolute value, and if its absolute value is less than or equal to 0.5 degrees, that person has a safe body temperature. What a trip! When you are out and about in the real world, look for other examples where absolute value might be used.